Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for your questions so our moderators can answer. I'll now turn it over to our speakers for today. So thank you and let's welcome Johan and Javier.
Hello, hello, hello. Good
Hello there.
morning, good afternoon, good evening. It's a pleasure for both of us to be here. Hello, Johan. How you been doing?
Hello, Javier. I'm good. Really. It's a cold day here in Norway, but it's nice and sunny. How about you? A bit warmer where you are,
All
I
good.
think.
All good, all good so far here in Argentina. Not so sunny, but warm. We're in the middle of summer. So, well, here we are today to continue with this great series, the Get Certified series on Fabric Analytic Engineer, DP-600. Today, our topic is semantic models and Power BI. So we have an hour ahead to learn and have some fun. A little bit of me. I'm Javier Villegas, as I said, from Buenos Aires. I work as IT director at Mediterranean Shipping Company. I am Microsoft MVP in the Data Platform Award area, and I'm also Microsoft certified trainer. I'm one of the local organizers of our community, SQL Argentina, with our show No Hay Data in Spanish. So if you feel comfortable with the language, please come join us. And we always have a good time. You have the QR code here for my contact information. Anything you would like to do to get in touch, please follow that link. So, Johan, back to you.
Hey there. Yes. Johan, I'm from Norway. I head the data and the AI department in a Norwegian company called, well, right now it's called Tower. It's in a temporary name. But yeah, I'm also a Microsoft Data Platform MVP, specializing in Fabric, but also Power BI. I also organize the Power BI Deep Dive Conference, which is from Denmark to Norway, 2 days with lots of deep dive, as well as running local community as Javier does. And you can see my LinkedIn profile there and my Blue Sky tag.
Good, good. So we also have great moderators today. They are live in YouTube for you to ask any kind of questions. They're going to be able to answer as good as they can. So say hi to Shen, to Mariano, and to Doher. So they will be there all the time. Hello, guys. Super happy to have you here. And well, let's start. So, what do we have here today? This is not an isolated session. This is part of a series. As we said before, we already had two sessions. This is the third one, and we have two more ahead, right? So we have on the February 24th, and then the final one on the 25th and the 26th. As you can see here, for some of them, well, actually for all of them, we have them distributed in two different times so we can cover multiple time zones. So super happy with Microsoft, with Reactor to give us the opportunity for us to present and for all of us to attend and keep learning on these topics. And get certified, right? That's the idea. Also, there is this new series, the Fabric Data Days, the monthly one, in where we're going to have great sessions every month, right? This month, on February 24th, we're going to have the first one, the session. So reach the QR code or the link to register for that session. Every month, we're going to have awesome sessions for you to keep learning. Something new, we also have the Fabric user panel. If you would like to share feedback, if you want to participate, if you want to influence on the Fabric roadmap, right? This is the place to go. You will have a lot of information, and you will have the opportunity to interact with community and with people who actually work with Fabric. Again, the QR code available, as well as the link. Our moderators will be posting the link in the chat for you to have it. We are also promoting today the hands-on workshop, right? We have this fabulous opportunity for you to attend to a hands-on event, which is Fabric Analyst in a Day. Remember the old dashboard in a day? Johan, I believe you were also part of the dashboard in a day. Now, with Fabric in a Day, this workshop is awesome, and for the one that can attend, definitely looking forward for you to go through. And of course, we have vouchers for the DP-600 or the DP-700 for free, right? This is something that Microsoft is also pushing hard, giving away this free voucher. So follow the QR code, the link, and fill up the form. And then it's going to be a couple of weeks until you get the voucher, right?
Yeah. Just remember, guys,
as soon as they finish this session, go there and do it.
Yeah, but just remember, there's no use asking for the certification voucher in the chat in YouTube right now. It will not pop up there. So follow the link, register, and if you're impatient, go to the Fabric community and check there instead. That's the place to go. Okay?
Yeah. It's important also to mention that the offer ends on February 28th, right? Or until the last supply. So definitely, as soon as we finish here, go there, check out for the link, and fill up the form. And then we have our conference, our big conference, the FabCon, right? The Microsoft Fabric Community Conference that will happen this year in Atlanta, Georgia, between March 16 and 20. This is going to be an in-person event. People from all around the world, people that work with the product, from the community, professionals, Microsoft employees. So definitely this is the place to go. Here there is a coupon, a code, FabLive, for you to save $200 with the registration. Also there, the QR code. Definitely for me, I'm looking forward to attend to the FabCon, which this year, by the way, I had the opportunity to deliver a session with a colleague, with a friend of mine. So yeah, super happy to attend to FabCon.
Yeah, I will be there
All
as
right.
well. We even have it. Remember, there's a community zone in FabCon as well. For instance, if you need to go and talk about certifications. I know I will be there on the Friday to man the certification booth, but there will be people there all week as well.
Yeah, I'm going to be there, I guess, on Thursday on the community zone, on the super users area. So check out for us. Stop by.
Now you know how we look now, so yeah.
Yeah. All right, so let's start with our content with the agenda, right? These are the topics that we will cover today. We will add measure to semantic models. We will design an scalable semantic model, and we will also optimize a model for Power BI performance, because everybody loves the reports in Power BI, but we also need some performance. We cannot be there just waiting, like this for minutes to get what the user wants, right? So this is going to be the area when we're going to talk a little bit about performance. We will also manage Power BI assets, and of course, like all the time, we need to enforce the security for the model. So these are the topics that we will cover today. Important to remember to everybody that this is live and interactive. So please, please, please go to the YouTube chat, ask all your questions, and the moderators are there for you, as we said. So let's start with the first topic: add measures to Power BI semantic model. Right here is where the fun starts. So we're going to talk about DAX, right? This is the language that we will use in Power BI, which is kind of some language for us to create formulas. By the way, DAX stands for Data Analyst Expression, right? And this is the language we will use in Power BI. Of course, we can also use it in many other places, but we're going to be focusing in DAX in Power BI. What we're going to be able to do with DAX here? Well, create measures, create calculated columns, and calculated tables, right? We're going to try to understand a little bit what are these things and how to do it and how to use the power of DAX to move on, right? So we're going to see the way to combine different functions, operation, constants, variables, and we're going to create any type of business calculations. With DAX, we're going to be able to turn our raw data into meaningful information. That's the goal, right? And we will see that maybe there are multiple ways to achieve the same thing or similar results in Power BI, right? But we will try to see which is the right one for each of the cases, right? So let's go to the next slide. So something important for you to remember from this slide is that we're going to create measures, right? Measures are dynamic calculations with user interaction. We can use the measure to do aggregation, to do sum, to do average, count, mean, max, calculate ratios, profit margin, gross, percentage, etc., etc., etc. This is what we're going to call a measure. And we have two types of measures: the implicit measures and the explicit ones. If we go a little bit to the implicit measures, right, we can say that, as the name stands, it can be automatically created when we do a drag and drop into a visual field, right? We can also identify them because you will see a sigma symbol. They are super quick to use and easy, and there are some limitations, right? Not too many, but we also have the explicit measures. What can we do with explicit measures? Well, basically, we're going to be able to create DAX formula with, from the bar that we have there. And we have a bunch of formulas that we can use, right? We will see that we will identify the explicit measure because we have the calculator icon all the time, and we can use within this explicit measure the full control over the logic, right? And as you can imagine, there are a bunch of best practices on how to use them and actually how to use DAX as a whole, right? For example, we can create a measure to do the sum of the total sales of a specific set of data. And then we can also use something more complex, like calculate the profit, right? With the total sales minus the total cost, right? It's important also to highlight that the measures are not pre-calculated, right? So they are being evaluated all the time on the fly. So that is why then Johan will explain a little bit more when we reach the area of performance, right? How to use it and in which case we need to use it. But definitely DAX and measures are one of the biggest strengths in Power BI. So we will have here one example of how to use DAX in a specific function, the calculate function, right? And we can, in this case, we can take the total sales of a specific year, and you have like a flavor on, the syntax of one of these functions, right? There are many more. We can use them, as I said, as a measure to then put it into our visual, right? They are super easy to use. We can, again, use the visual interface, but, then if you get into DAX, you can go over there and do more complex things. If we go a step forward, right, we also have the calculated columns, right? These are columns that we will add to our existing data set, right, with one specific function. For example, total price, average, percentage, you tell me, right? So if you have a table with, for example, 1,000 rows, right, you will have this additional calculated column with this formula that will generate the calculated column on the fly, right? Important to mention that they are evaluated row by row, so it's going to be key when we specify the calculated column on the performance area, right? Again, Johan will tell us more in a bit. These calculated columns are stored within the model, right? And of course, they use some space. So, within your PBIX file, it will increase the size of the file, right? So important to bear in mind the performance, right? Because again, if you have a data set with 1,000 rows, 1,000 values, maybe it's not that much. But if you have billions and you use multiple calculated columns with, complex DAX functions, you may have some impact. So you may have to be super, super careful when you use them, right? But they are there for you to use them, absolutely. And then we have calculated tables, right? These are tables that we can generate completely with DAX. For example, create a table with a calendar, right? Create, a summary table, extend the structure of our model. So again, using DAX, we can also create new tables, right? Calculated tables that then we will use to combine with the data that we import, that we have in our data set, right? So remember, DAX for calculated columns and calculated tables, right? The difference is that one is a column within existing table, and the other one is a brand new table that it will help us to accomplish what we are looking after. And here we have in this slide, a summary of, calculated column and calculated measures, and decide when to use each of them and the main characteristics of each of them. So it's important to remember this slide, because when you get into Power BI, when you get into DAX, into measure, into calculated columns, in tables, right, there are certain limitations that will definitely affect the end result and the performance. And with all that, we have to sit down and wait for the report to finish, right? So please, if you have to remember one slide, I believe this is the right one.
Yeah, and I think just skipping in, one thing that is important to remember is Matthew Roche from Microsoft. He put this, I mean, it was standard knowledge back in the day as well, but he's put it into Maxim. Do as much upstream as possible and as little downstream as possible. So whatever you can do in the database, do it in the database. Whatever you have to do in measures or in calculated columns, do it there. But whatever you can do before you start applying transformations or the logic in DAX, the better it is.
That will definitely help you a lot with the performance, right, Johan? If you can do, the right thing in the right place, let's say, right?
Yes.
Absolutely. So you want to take over and explain us and this topic, design scalable semantic model.
Yeah, sure. So one of the keys to make manageable and performance solutions with large data sets is to have the best model design. So we'll discuss some model scalability and why it's important, and what tools exist in Power BI or in the ecosystem to help you and your team accomplish those goals. But before we talk through scalability, let's first define what we're talking about, because what the hell is enterprise? Sorry, pardon my French. So enterprise, we're not talking about Star Trek, we're talking about corporations. So enterprise scale data is, sorry, one slide back, by the way, Javier.
Yeah.
So enterprise scale data is massive, it's complex, diverse, rapid, and of course, as with every other company size, it's valuable. So it requires a unified data platform that can handle all the different aspects of data analytics. So from data movement to data science. And because enterprises are larger in scale than smaller corporations or small companies, you need to have the scalability in place. And of course, it has to be cost effective. Again, this is not really enterprise specific. Everyone wants to have cost effective. But Fabric is such a platform, and it offers a lake-centric data warehouse, a serverless data integration service, and a comprehensive suite of data engineering and data science tools. So if you're familiar with working with enterprise data, it might be helpful to understand that Power BI is kind of the next generation of analysis services, or SQL Server analysis services. It's the same technology under the hood, at least as the tabular model and Power Pivot for that matter in Excel. And it is what we call the Vertipack engine. And then we can go to the next slide. So scalability in this context refers to making sure that we build data models that can handle the growth in the volume of data. And data models that ingest thousands of rows may certainly grow to millions or billions of rows over time. And the model must be designed to accommodate that kind of growth. And it is important to consider that your data will grow and or change, which then increases the complexity. So, I mean, if you're working in a small mom and pop shop, you might not have to think about scaling to billions of rows. But if you're working in a larger company, you need to think about scalability when you start off designing even smaller things. So you need to have the flexibility to allow your models to change. you need to make sure that the models can handle the increasing volume and maintain the performance that is acceptable. It's, as Javier said, 4 minutes waiting for a slicer or for a visual to show up is not something that people will continue doing. And of course, try reducing complexity. You're still one slide back, Javier. Reduce complexity, because the simpler the models, the easier it is to scale them over time, and it easier is to manage them as well. So keep things simple. The KISS principle is very important. But how do I design for scalability? Well, Fabric was, of course, beyond the data model, designed for enterprise deployments. So the premium capacity tiers before, I mean, some of you might still be on them, but the Fabric capacities that now takes over offers greater storage capacity and allows for a larger individual semantic models depending on the SKU of the Fabric capacity you're on. And when you're opening up a workspace and attaching that to a capacity, you can put in whether you want to support larger data models or not. But implementing Fabric, the Fabric-only large semantic model storage feature, again, that's on the workspace level, enables data to grow beyond the Power BI desktop, which is, I mean, the PBIX files, the limitations that are in the files themselves. So again, going to the workspace, when you're attaching that to a capacity, you are allowed to enable large semantic models, and that then lets it grow beyond. Another important consideration in designing the scalability is when using Fabric, is making sure that you have the right capacity. You'll need to work with your Fabric admins to determine which licensing SKU that is available to you. I mean, your company might have some limitations on not allowing anything above F64s or anything above, say, 248s. So making sure that you have what is available to you in mind when you are designing. And if you're having performance issues on your Fabric capacity, work first to optimize the model, and then work with your Power BI admins or your Fabric admins to monitor the Fabric capacities. Of course, it is sometimes hard to decide in advance what capacity level you need to be at. But if you work hard on optimizing your models first, then when you've started using this and you're working with the admins to monitor and see what kind of capacity unit costs your models have, it's a lot easier to plan for what kind of capacity you actually need going forward. But
there are also a bunch of ways for you to monitor the capacity usage, right? But yeah, as you said, the first thing that you have to go is go tune your model, because for sure, this is the number one place to start with.
Yeah, I've seen bad model decisions or modeling decisions killing a capacity quite quickly, and just by going in and doing a couple of minor changes, again, keeping in mind this upstream first, downstream last approach. Just by moving things away from the front end, we suddenly managed just fine on the smaller capacity that we were running on. So modeling first, or model tuning first, is a very good approach to this. At the most basic level, it is important to understand that Fabric capacities require sufficient memory processing. You'll probably need around double the amount of RAM to process your data model refresh. So if you have a 40 gigabyte semantic model, you will need at least 80 gigabytes of memory available in the capacity to process that. Right, on to the different sum. So we have different types of storage modes, and you can, of course, choose between them, and Direct Lake being the last to come in. Traditionally, we have had the import mode and DirectQuery. And then you've gotten Direct Lake now with Fabric. And in addition, we also, a couple of years ago, got the Composite Model. And if you click one more time, you see that the Composite Models combine import and direct query, which means that you can connect directly or connect and import data from, say, another semantic model. And then you can do direct query against other tables on your Fabric instance. So each of these 3 different storage models, or 4 storage models, actually have advantages and disadvantages, and you need to think about which one of them or what you need from each one to make sure that you land on the right one. So import evolves around importing and storing data within the Power BI file and in the Vertipack engine. And that offers the most flexibility, and of course, because it does everything in memory, it is the fastest. However, it requires periodic refreshes of the data and all the data to keep that data current. That means that the data is only as up to date as the last refresh. Guidance for import models also applies to other storage modes. You should always choose import if your model allows. Is it small enough to handle probably in memory? Then that is the way to go. Of course, if you need to have things up to date all the time and your capacity limits the number of refreshes you have, well, maybe DirectQuery or even Direct Lake might be a better option. But default should always go to the import mode. So think about things like connecting to views instead of tables. And doing this means that you can transform the data that is in the background tables into views. Again, keeping the transformations in the database instead of in your model or in the Power Query part even. Only include the necessary tables, rows, and columns. The less rows and the less columns that you include in your model, the less data will eat up the available memory for you. And of course, the less the Vertipack engine has to look through the different rows to pick up everything. Vertipack engine is columnar, which means that, of course, if there's a column that you don't need, remove it, and that data is just a waste in the memory side anyways. And use appropriate data types. So integer for ID instead of string, because the Vertipack engine handles the ID columns better when they're integers. Making sure that the cardinality of the rows or the columns is also optimal. So if you have a date time column, split that in 2 instead, because that means less cardinalities or less number of rows within each column. Make sure that you use query folding, so that that also reduces the work done in the Power BI engine and increases the performance. Direct query, yeah, you can just keep it on the same slide still. I'm yapping around. Direct query allows you to query data directly from the source without storing it in Power BI. So it's ideal for handling large volumes of data and near real-time delivery. You don't need to refresh in that way. But the thing is, it is slower performance compared to import mode, because it's as fast as the underlying data source that you're querying. So to boost the direct query performance, you probably need to have a fast engine behind, whether that is a database or it's a KQL engine or something else. The speed of that engine is what limits the direct query. And it also has limited modeling capabilities, which means that you need to think about that as well if you really need to have that kind of modeling in place. So simplified DAX measures to avoid complex calculations. Apply dual storage modes for dimensions that are related to fact tables. Use the assumed referential integrity property on relationships. That also speeds up. And avoid relationships on calculated and unique identifier columns. Direct Lake. So the newest kid in here allows querying data directly from a Microsoft Fabric Lakehouse, which means, or also a warehouse actually, but it means that you have to have that as the storage mode for the data that you're querying. But it means that you don't have to store it in the semantic model itself. So it makes it ideal for handling large volumes of data. But it is not the best of both worlds. So it's not, it has a specific use case. It is optimized for quickly loading data into memory from delta tables in Fabric. And while it offers quick access to large data volumes, it requires setup of that lakehouse or warehouse. And you need to make sure that your delta tables are optimized and it tunes for optimal performance. And remember that even though this it doesn't store data in the semantic model, it still requires the same amount of memory, which is important. And it allows for an incremental refresh. So it's, again, in some use cases, it's a really good mode or good mode. In others, it might not be. And composite modes can mix import and direct query and integrate multiple direct query data sources. So this is many-to-many relationship without need for bridge tables. It offers flexibility on querying and reporting capabilities. It does require periodic import from refresh for the import mode tables and might have some performance impact because it's combining different sources. So make sure that your backend sources have sufficient sources, minimize number of literal values in source queries, and keep the cardinality of columns used in relationships low. And I mean, keep the cardinality of columns in your model anyways low. That's always the best practice. So best practices for import mode is, of course, only bring in data that you need. We mentioned that already. And another, I mentioned this Roche maxim of keeping or doing as much upstream as possible and at least downstream as possible. The other key maxim in Power BI is star schema all the things. Yes, star schema all the things, because Power BI is optimized for star schemas. Avoid wide tables. So the more that you do in the data beautiful data model, the better your performance will be. Power BI also support multiple fact tables, which means if you have a wide table but you don't really see it or you need to have everything in there, try using several different fact tables. And again, you can use views for that. You don't have to recreate the physical tables. Pre-aggregate data before loading the model, if possible. Reduce the usage of calculated columns as much as possible, because calculated columns and calculated tables are created after the data has been imported and after that data has been compressed, which means that data will be stored uncompressed in your model. I mentioned high cardinality. Again, that is just very important to avoid those, because for the compression algorithms inside the Vertipack engine handles lower cardinality a lot better, because that means it can compress each column the most effectively. Data types that have been mentioned, they are also very important in this. Do not use bidirectional filters if you can, because that also very much drags the performance when it has to start looking in and trying to interpret which way we should look now. So yeah, please don't do that. Create a data table on the source instead of creating it in Vertipack if you can. And do not rely on auto date time calculations. And query database use rather than tables. It's a given, and it also makes it easier for you to reduce the number of columns and rows available to you. Consider partitioning or incremental refresh to avoid loading data that you don't need to. Make sure that query following is achieved, and if that's not possible, you can have take the opportunity to work with another data engineer to move that transformation upstream. And I would rather do that first anyways. So for import mode, sorry, that was for import mode. I mean, some of this is basically for everything, but for direct querying, make sure that you have that assume referential integrity in place on all the relationships. That forces the queries to use inner joins instead of outer joins. Again, boosting your performance. Limit the use of bidirectional filters here as well. Try to reduce the complexity of your DAX calculations. Again, DAX calculations hit after you've imported or after you've hit the SQL queries, or it has to be translated into SQL before it hits the SQL. Of course, that means that if you are using a SQL-enabled backend, you might be using something else. But again, it has to translate the DAX into whatever query language that the source is using, which slows things down. Calculated columns is again a given, calculated tables again a given, and try not using relationships on unique identifier columns as much as possible, and use dual storage modes for the dimensions that are related to facts in DirectQuery. Then we are on the enable large semantic models. So I think we are a bit, you're clicking, yeah, there we are. So I mentioned that Vertipack compresses quite effectively in-memory cache using the columnar format, and again, making sure that the least granularity or lowest granularity that you can reach is making the compression even better. With large semantic models storage formats enabled, you can go beyond the limitations that are in the Power BI format, but then that limit is then transferred to the capacity that you're running on. So make sure that when you're doing this, check with admins if they have some maximum size sets, and check, of course, with the SKU level you're on to see what kind of limitations are there before you start enabling those larger formats. Of course, when you're enabling the large format, the semantic model must be stored in a workspace allocated to a large enough array capacity. And we've mentioned already how you do that. Star schema principles. Next slide. Star schema all the things. That gives you the best model. And of course, star schemas is referencing to the facts and dimensions surrounding it. If you have dimensions that are attached to dimensions, you start going to Snowflake, and while that is probably okay, it doesn't really, it might not affect the performance that much. Star schemas are always better in an approach that you can have here. You can see here the model diagram on the picture is from AdventureWorks. And it shows the star schema comprising a single fact table, the fact reseller sales, and then the other tables are the dimension tables to support analysis. Again, fact tables being mostly numbers and IDs, and the enrichment of those IDs are in the dimensions. And it's unusual that a model table isn't related to another model table. And they are, and sometimes you might have tables that are not connected to others, and they are a valid model design called a disconnected table. And these disconnected tables aren't intended to propagate filters to other model tables, but instead it accepts user input, maybe we visual slicer, and then allows model calculations to use input values in a meaningful way. So for example, consider a disconnected table that's loaded with a range of currency exchange rate values. And as long as a filter is applied, that allows you to filter by a single rate value. And then a measure expression can use that value to convert the sales values. Model relationships relates one column of a table to another column in another table. And And there's some specialized cases where this isn't necessarily true, and it applies only to multi-column relationships in DirectQuery models. And it's not possible to relate a column to a different column in the same table. Worth noting. And you can use the relational database concept to store parent-child relationships. For instance, each employee record is related to reports to employee, but you can't use model relationships to generate a model hierarchy based on this type of relationship. This used to be possible in MDX or in the multidimensional cubes, but in tabular, it's not there. You can go and look up the documentation on parent-child functions to see how it's possible to do it in the tabular models or Virtual Engine instead. And inside the Power BI desktop model, you can interpret the relationship's cardinality type by looking at the indicators, whether it says 1 or star, which means it's either a 1 to many, so 1 to star, or vice versa. And you can also click on or hover over the relationship line to highlight the columns available. You can see on the screen here the red marks as well. Relationship functions can be used to manage and utilize relationships between tables, even inactive relationships. So you can have multiple relationships enabled, but only one of them can be active at any given time. So if you use related index, that returns a related value from another table. Related table evaluates a table expression in a context modified by the given filters. Use relationship, then you specify the relationship to be used. Say that you have in one table you have a date, and in the other table in the fact table you might have 4 or 5 different dates. So say order date, production date, best before date, something else. And then you can say, for this calculation, I will use the relationship best before date. In this relationship, use relationship for production date, which means that you don't have to have multiple date dimensions to be able to calculate everything. You can use those use relationship code instead. And cross-filter specifies the cross-filtering direction to be used in a calculation for a relationship that exists between 2 columns. Next slide. So understanding relationship values. So the model relationships from an evaluation perspective is classified as either regular or limited. And it's not a configurable relationship property. It's inferred from the cardinality type and the data source of the 2 related tables. And it's important to understand the evaluation type, because that might be a performance impact, or there can be consequences if the data integrity is compromised. You have regular relationships, which is when the query engine can determine one side of the relationship, and it has the confirmation from the one side to contain those unique values. Limited relationships are when there's no guaranteed one side. So can be relationships using many-to-many cardinality types, or the relationship is a cross-source group, which only is a case in the composite models. Optimizing for the Power BI solutions. So we know that how to design semantic models with scalability in mind. And while this is critical for enterprise data, it is also valuable for all data solutions. When facing performance issues, first thing you should do is verify that all of the guidance is already in place. So if you have a table with billions of rows connected via DirectQuery, you're likely affecting the database performance. And again, this is long-range queries every time users interact with visuals using that data. Additionally, making sure that you only include necessary data by limiting in the views. Data types are correct, relationships are configured correctly. You can also optimize your solution at different architectural layers. So data source, data models, visualizations, and the environments are all the different layers that we have here. Again, much upstream as possible, as little downstream as possible. Then next slide. So tune report performance. When you've completed your report, the performance of that report depends on how quickly the data can load onto the report page. So you should always test this in the Power BI service to see how it works there. It works on my machine is not really an excuse because again, that's in a desktop. Making sure that it works on the in the Power BI service. And if you experience any issue yourself, or if the report users have reported issues, you need to investigate the cause of those issues and take measures to tune the report. You can do things like the Performance Analyzer tool within Power BI Desktop, and that allows you to find out how each of your report elements interact and provide your logs with measuring time duration, how each of your report elements perform when users interact with them, and so on. But before you run that performance analyzer, make sure that you clear the visual cache and the data engine cache. Otherwise, those results will not be accurate. Also, you should set up the report so that it opens on a blank page. That also makes sure that you don't fool yourself with the visual and data cache. And when you've cleared the caches and open the report on blank page, to run the performance analyzer, go to the View tab, select Performance Analyzer, and then select Start Recording. And then interact with the report as you would expect a user to do. Or if you aren't sure about that, maybe sit down with the user and open up and let them click. And then when you're finished interacting with it, hit the stop button. And then you can go through and analyze the results in the Performance Analyzer pane that you can see show screen here. And you can see the name of the different interactions as well as the duration in milliseconds in the table here. And it shows things like DAX queries, visual displays, and others. And that's the time for the visual to prepare the queries and wait for other visuals to complete or perform all the background operating tasks. And this analyze test will help you, of course, understand more on what's happening. Think also about the metadata, which is the data about other data. And metadata in Power BI contains information on your data models, name type, data type, and so on. It also tells you when the file was last modified, the data refresh rates, and a lot more. And you can use Power Query Editor in Power BI Desktop to examine the columns, rows, and values for the raw data. So we'll think we had some knowledge checks, but I think we're only 8 minutes out, so I think we can skip the next knowledge check. But you can look.
Let's move on. Yeah.
And think about using. So you try to think about using reusable or make assets that can then be reusable. Because when you first were introduced to Power BI, you learned how to use get data from various sources. That's SQL Server, Excel files, or text files. And creating the same or similar semantic model for each report is tedious. And who wants to develop reports on top of exact semantic model? Try thinking of a semantic model as the back layer. In the old days, we used reporting service in front. I mean, I'm old, you know. And reporting services queried analysis services, which then handle that semantic model part. Power BI combines both of them, but you can still separate and use several reports querying one single semantic model, which then makes it easier for you to reuse whatever core assets that you have. And you could also then create specialized semantic models for other solutions. Be careful not to have a too large semantic models. A semantic model to rule everyone is a bit too much. That will be hard to scale, hard to manage, and so on. But let's jump forward. We are running out of time, so let's look at the enforced semantic model security. Because there are lots of things there, lots of data to go through. So to look at the security, you can use workspace security to make sure that the data is shared correctly with the Active Directory users. You can secure reports the same way, locking them down with Active Directory, or sorry, Entra ID users, Entra ID groups. You can share a single report, or share a workspace, or share an app. And say you can make one report where employees in a specific department can only see the sales for that department. You can say that Maria can, and I think we've lost the slides.
Hi,
Yeah.
Johan. I think we lost Javier altogether.
Yeah, we did. Let's see if I can share my screen then.
Great.
Let's see, I just need to swap here. Oh, there's Javier is back.
Yeah. Sorry about
Can you
that.
try sharing again, Javier?
Yeah, I'm there.
Yeah, good. Yeah, it's not the first time we've crashed in the middle. I've done that myself, so
yeah, a little bit of a crash.
Yeah, that's always a problem when you're using a browser like we are doing to stream this.
Yeah.
Anyways, so there are two different ways of implementing row-level security in Power BI, which is the level below the workspace or report level security. You have a static method and you have a dynamic method. Row-level security uses a DAX filter as the core logic mechanism, and this model will demonstrate how you can implement. This will make sure that you can implement the row-level security using DAX to ensure that only the appropriate person is seeing what they need to see. Of course, we then have to make sure that we're using the star schema design principle that we've already covered. And then you are setting up a rule, and the rules are evaluated on the row context again, which is why it's row-level security. And when that expression is returns a true value, the user can see the row. Otherwise, they can't. And the static rules are the simplest. So they create access restrictions on the table rows, and you can also then restrict access on a particular region, for example. Dynamic rules are specific DAX functions that return environmental values as opposed to the constant ones. So you can use things like username or user principal name and custom data that returns the custom data property passed through the connection string, and then that can validate the role and what the users can see. You can also set up role mappings, but they need to be set up in advance for users accessing Power BI content. And role mapping involves assigning Entra ID security objects to the roles, and then security objects can be user accounts or security groups. And of course, use single sign-on for DirectQuery, because then that will pass through down to the data object behind and enforces security on the data set itself. We are so quickly on this, so we'll just browse through the different static methods and go to the exam preparation, I guess. Yeah.
Let's wrap up in the last few minutes that we have. Well, this is definitely the slide for you to start preparing for the exam. You have, there are a bunch of sessions that we had before in the Reactor webpage that you can go through them, definitely. But here you have direct links for your preparation for the checklist. You will see all the on-demand session, and definitely with all this, you will be ready to take the exam. Right?
And as you understand from us yapping so much, there is a lot of content to go through. So make sure that you read up through that.
Yeah, and you go through all this. Here you have the vouchers, as we said before. Continue with all that is happening in February, right? There are 2 more sessions ahead of this one, just to wrap up the whole series. Tune in the Fabric Data Days for the monthly event. Join us in the Fabric user panel, as we said before. Don't forget about the instructor-led hands-on workshop, Fabric Analyst in a Day. We hope to see you in the FabCon in Atlanta in March. Hopefully, some of you can make it. And we thanks again our great moderator. Without them, we won't be able to reach this point. So again, thank you, Shen, Mariano, and Oher for being here. So Johan, it was great to share with you the stage. We have some technical issues at the end. Sorry about that, but I believe that we were able to accomplish what we wanted to. So you want to wrap up?
Yeah, no, just thanks, Javier. Nice having a presentation with you finally. And thanks to everyone who watched, and thanks to the moderators. I hope you guys watching here made them type fast. Lots of questions, I hope. But with that, thank you very much, and hopefully see you in FabCon.
Thank you. See you.
Thank you. Thank you, Javier. Thank you, Johan. And thank you to our moderators in the chat. And thank you all who joined our session today. Before we end the session, please take a moment to have a look at our survey. We are always looking to improve our sessions and our experience. So if you have any feedback for us, we would love to hear what you have to say. The link is in the chat, or you can find it on the QR code. We'll see you on the next one.